Alright, so in this video I'm going to go over logarithms, and we're just going to go over the basic idea of what a logarithm is and the basic definition of a logarithm. So some of the key things that I want you to remember when we're looking at these is that a logarithm is an inverse of an exponential function. So as long as you keep that in the back of your mind, this will be a lot easier to understand logarithms. So it's the inverse. There is a number e, and it's approximately about 2.7, and we can use some calculus to determine what this number is, but for now all I want you to do is just remember that this is a number. So when I use it in terms of the math that we're going to be doing, remember that it's a number. It's kind of like pi. You know, pi is 3.14 and goes on forever. It's a irrational number. E is also an irrational number. Okay, so it's not a variable, this is a number. So let's take a look at the exponential function f of x equals 2 to the x. So what I'm going to do here is I'm just going to make a quick xy table, and we're going to use negative 1, 0, 1. We're going to get 1 half, plug that in, we're going to get 1, 2, and then if I wanted to use 2 we'd get 4. So I'm going to plot these points. There's 1 half, there's 1, 2, and 2, 4. And of course, we get our exponential growth function that looks like this. In my class, I mentioned that we wanted to graph the inverse of this. And if we graphed the inverse of f of x, so we're graphing f inverse of x, we would take these and switch them. So our x and y in this case would be 1 half negative 1, 1, 0, 2, 1, 4, 2. Okay, so 1 half negative 1, 1, 0, 2, 1, and 4, 2. And notice, yes, this is a reflection about the line y equals x. And if we've studied inverses a little bit before, we would notice that anything that is a reflection about y equals x is an inverse. So notice that, and we also noticed that this inverse looked a lot like a logarithm function that we did in our 12 parent functions. We have a horizontal asymptote of 0, and now we have a vertical asymptote of 0. And this, yes, this is actually a logarithm. So a logarithm is the same as an exponential function. So if you remember back though, when we wanted to solve, if you looked at the inverse function video that I did a while back, and we wanted to solve this for the algebraically and determine the inverse, we would first take and switch that to be a y. So we'd take y equals 2 to the x, and then we would solve for x. Well, we got a bit of a problem here. We don't have any real algebra to solve for x. So in order to solve for x, to bring this exponent down, we needed to create a new terminology, and that's where we get the terminology of logarithms. So when we do this, this is going to be our exponent. Okay, so this we know is our exponent. This is our base. We know that's our base, and this is what we call our logarithm. And so we're going to convert it into logarithm form. So right here we're going to convert to logarithm form. And the way that converts is we're going to have x equals log, and then our base is 2, and then inside our log is our logarithm, which is y. So now that we've done that, we can use our inverse notation. And when we use our inverse notation, remember we switch the x and the y here. So we get y equals log base 2 of x. And again, I don't want you to get confused here with this being the inverse. Okay, inverse of x equals log base 2 of x. So what I don't want you to get confused in is that this conversion always happens the same way. So what I'll do here is right here, right in this box right here, I'll show you what the conversion is. And the conversion is always going to be the same thing. So we're going to have, I'm sorry, let me use a different color here. We're going to have, anytime we have a equals b to the x, the way we convert to logarithm is we're always going to have the power x equals log base b of a. Okay, this is the logarithm conversion. All right, so let's take a look at a couple of examples and kind of explore this just a little bit more, an understanding of what a logarithm is. All right, so we move on to our first example here, and our first example is let f of x be 3 times 2 to the x. We're going to determine the inverse and sketch the graph. So we could make a table of values for x and y of f of x. Let me use -1, 0, and 1 here. So -1 is going to give me 3 halves. This is going to give me 3. It's going to give me 6. So I can do this the same way I did before, in that I created my graph of f of x. Okay, this one goes up pretty quickly here. And then I reflect this to make my graph of inverse of x. So I'm going to get 3 halves, -1, which is right here, 0, so 3, 0, and 1, 6. All right, and there's my graph. Okay, so this right here is our graph of the inverse. So let's solve the inverse using our formula from before. So we're going to take and make this y. So we're going to go y equals 3 times 2 to the x. And the way we're going to solve this is that we are going to first isolate 2 to the x. Just like when we solved exponents, we're going to isolate this. So I'm going to divide 3 over. So y over 3 equals 2 to the x. And now we're going to use our logarithm conversion. So if you don't remember it, it's a equals b to the x is going to convert to x equals log base b of a. So we're going to convert, so we're going to get x equals log base 2 of y over 3. And now I'm going to switch the x and the y, and I'm going to come up with my final answer here for my inverse. Oops, x over 3. And I'm going to write it in terms of the inverse. So f inverse of x is equal to log base 2 of x over 2. Okay, so we use our conversion here to find our inverse here, and we end up with this graph here. Okay, so let's take a look at a few more examples. Again, with the next ones, you might want to stop the video, pause it, and see if you can do the problem. Okay, this one you might want to wait a little bit because I kind of want to tell you what this is. Now you can obviously let's go ahead and just do the work that we did last time. So we're going to go y equals e to the x, and we're going to do the same thing here. Now we're going to do a logarithm, so we're going to switch this to x equals log base e of y, and so we're going to get an inverse of log base e of x. And now we know that the log e, or I'm sorry, e to the x is the exponential growth function. So I'm just going to sketch the graph of the exponential growth. Let me use a different color here. So the exponential growth function looks like this. Okay, that's e to the x about. And we know that the inverse of that is going to look something like that, but go the other way. Reflected about the line y equals x. So like this. Okay, well, we've got a special term for log base e, and it's called the natural log. So anytime we see a log base e, we're going to replace that with an ln of x. Okay, so ln means log base e. Anytime you see an ln, you can replace it with log base e. All right, let's take a look at a new example. I've got 2 more examples for you today. On this one, see how much you can do on your own. Okay, so we're going to go straight. We're not going to graph it or anything. We're just going to solve and find the inverse. So again, to find the inverse, we're going to make y equals -2 times e to the 2x plus 1. Now again, you always want to solve for this part, the exponent part, first. Okay, so we're going to subtract 1 over. So we're going to have y minus 1 equals -2 e to the 2x. Then we're going to divide by negative 2. So we're going to have, I don't like the negative in the bottom, so I'm going to switch the top here to 1 minus y over 2 equals e to the 2x. Now we're going to use our logarithm change. And our conversion again for logarithm, I'll write it here again, a equals b to the x, and we convert that to x equals log base b of a. So this goes here, b goes to the base, x goes there. So we're going to have 2x, because this is the power, so we're going to have 2x equals log base e of 1 minus y over 2. Now, if this is a review for some of you and you know some properties of logarithms, I'm going to go over that in the next video. You don't have to do, you really don't have to do any simplifying here. But we do have to solve for x. So we're going to divide everything by 2. Okay? And I'm going to get x equals, I'm going to put the half right in front, 1/2. Log base e is ln, it's the natural log, 1 minus y over 2. There's the bell, but we're going to keep going here so we can get this done. And then I'm going to have f inverse of x equals 1/2 ln of 1 minus x over 2. And this is our answer. Okay, I've got one more example that I'm going to speed through here for you, and we're going to try to get this done before I get students coming in my classroom. Okay, so example 4, again, pause it if you can and then try to solve it yourself. So I'm going to have y equals 2 plus 3 times e to the x minus 2, subtract the 2, and then I'm going to divide 3, y minus 2 over 3 equals e to the x minus 2. I'm going to use my formula to switch, so x minus 2 equals log base e, which is ln, of y minus 2 over 3. And then I'm going to add 2 over, we get x equals ln of y minus 2 over 3 plus 2. So f inverse of x is equal to ln of x minus 2 over 3 plus 2. Alright, so that's some basics of logarithms. Hopefully you got a lot of that. I'll see you soon.